Good day from ChemHelp ASAP. We're going to discuss alkanes, naming them and how to interpret alkane names. So alkanes. Alkanes are organic molecules that contain only sp3 hybridized carbons and hydrogens. So they have very few features. Alkanes all carry this suffix ane, ane. And then they also have, if you have a suffix, you have something that comes before the suffix. That's the prefix, and that tells how many carbons we have in our longest chain. So on the left-hand side of the screen, I have a number of molecules drawn. The first is methane. Note that it has the suffix ane. It's going to have sp3 hybridized carbons, and meth means one carbon. So that's our prefix that tells us how many carbons. Ethane. That's the prefix that means 2 carbons, and we've shown that as a Lewis dot structure, 1 and 2. Now propane, I've drawn this now as a line angle structure just to make it a little bit more compact, but prop tells us we have 3 carbons, and of course it's propane, so it's sp3 hybridized carbons. There are the 3 carbons. Butane, but tells us that there are 4 carbons, and these aren't prefixes that you probably encounter in other places, so these are special prefixes. Thankfully, once we get to longer chains like pentane, this prefix is a little bit more standard prefix for 5, and then there's hexane, which has 1, 2, 3, 4, 5, 6, and then we keep going up. Heptane, octane, nonane, decane have 7, 8, 9, 10 carbons respectively. So this is how we talk about the straight chain alkanes. Now, these normally, the name is based on the longest continuous chain of carbons. So I've already drawn it to the left, but this is hexane. Now hexane can be drawn many different ways. This is also 6 carbons, 1 through 6. That is also hexane. If we were to draw the molecule like that, that is hexane. There are lots of ways that we can draw hexane. These are all hexane because they're a contiguous chain of 6 carbons. So these are all hexane. They're just drawn different ways. Now, the most common way is this one at the top, where we draw it as a straight chain sort of going across the page. Now, our alkanes can have groups coming off of them. So this is hexane, and now we can put another line coming off here. So here is our longest continuous chain, and that determines the name. This is some kind of hexane, and it has another carbon group off here. And you could say, well, that looks like a methane coming off our hexane. But methane is its own molecule. We can't call it methane hexane because we'd be saying there are 2 molecules. We need a way to name a group, an alkane group. And so this is called an alkyl group, and we use this YL suffix. So this isn't a methane, it's a methyl. So that is a 1 carbon chain. You can imagine if we had a 3 carbon chain, it would be a propyl group. Or a 6 carbon chain would be a hexyl group. So with the YL, we're saying that is not the molecule itself, but it's dangling off some other larger molecule, some larger alkane. So let's see a couple examples of this. There's one that we've already drawn. Here is another. Both these are coming off of our longest continuous chain, is 6 carbons. And note that these are different structures. In one case, we have the methyl group coming off the 2 position. In another chain, we have it coming off the 3rd carbon. So these have different names. These are isomers. One we would call 2-methylhexane. And the one at the bottom, we call it 3-methylhexane. These are isomers. But we need to we'll use numbers to indicate where groups are coming off of the main chain. In this case, the main chain is alkane. There's also another feature you encounter. You often have rings. So this is 6 carbons in a ring, and so, whoops, 4, 5, 6. So we would call this a cyclohexane. So you'll see a cyclo prefix to indicate that there is a ring involved in your structure. Typically, you take these molecules and you work them backwards. You work from the end of the name. So for 3-methyl hexane, we know that, okay, we have an alkane. It's going to have sp3 hybridized carbons. We're going to have 6 carbons in our longest chain. And look, we have a group in front. Off the number 3 carbon, we have a single carbon group, a methyl. So when you unravel these names, you tend to work from the end, the right-hand side, and work backwards through the name. So this is just a very brief introduction into naming alkanes. There are a lot of potential rules, but personally, I don't think we need to know all the rules. We just need to be able to know intelligently how to handle a name when we encounter it. And these are some of the simple introductory rules.